Okay. Okay. So now potassium is in solid state and chlorine is in gaseous state. Okay. So this one is, first of all, you will write enthalpy of formation for ionic compound. Clear? So it is basically the first step. Even before atomization, you should write enthalpy of formation. Okay. It means you have to write the ions that are involved in the in the formation of this ionic compound that is given in the question. Okay. First of all, the first step is enthalpy of formation, and you can see the arrow is downward because the definition of enthalpy of formation suggests this downward arrow. Okay. When we say 1 mole of a compound is formed from its elements in their standard state. So you should know that enthalpy of formation is basically potassium half chlorine is forming potassium chloride. Okay. So now this is the direction from elements to compound. So that's why we are drawing arrow downward. It says that these are conversion. This is the conversion from elements to ionic compounds. That's why we have drawn this arrow downward. Okay.
Yeah.
Just keep in mind the definition, then there will be no chances for mistake, because obviously we know that one compound is forming from its elements, so arrow is toward ionic compound. So that is the correct arrow. Okay. Next.
When we know that like we have to
Mhm.
put change in HAT, change in HF, like that.
Change in HF, we will discuss it later. First of all, just
It's
focus
coming,
on
it's coming. We didn't reach it. Acha, okay.
yeah, first of all, just focus on how to draw, and then it would be clear. Okay. When we will start calculation later. Okay. After drawing, we will discuss calculations. Okay.
Yeah.
Yeah. Then next step, as we have discussed, next step is after formation, next step is atomization. And according to the definition, atomization means conversion of substances into their gaseous state, right? So just write. It means the next step is you will draw a line and convert this potassium and chlorine both into their gaseous state. Chlorine is already in gaseous state. So you should write potassium in gaseous state and chlorine, now atomic form of chlorine, in gaseous state. Clear? So now this enthalpy would be called as enthalpy of atomization. And now you can notice the arrow. Arrow is toward gaseous ion, because if you write the straight equation, it would be like this. Potassium solid converts into potassium gas. So you can note the arrow. Arrowhead is toward gaseous ion. So in this one, we are also making the same thing. Okay. Arrowhead is toward gaseous ions. Okay.
Yeah.
Third step, ionization energy. And again, the definition, focus on definition. Ionization energy is the energy required to remove an electron from isolated gaseous atom. Okay, now tell me, from which element, potassium or chlorine, will lose electron?
Which element? Potassium
Or
or
chlorine? Or chlorine. We have two elements, potassium and chlorine. Which element will lose electron?
losing potassium.
Potassium. Very good. So it means in ionization, in this step, in ionization energy step, only that element will be changed to from potassium to K plus, that is losing electron, because ionization energy means energy required to remove an electron from isolated gaseous atom. So we will lose electron from that atom that has potential to be to form a positive charge, right? So it can lose electron. Chlorine will not lose electron. So chlorine, you will write chlorine as it is, but write potassium in its positive form. Okay, because it is losing electron. Okay.
Yes.
So in this step, you will change only that element which is converting into positive state. So let's say potassium is going into the positive state and chlorine is as it is. And then you will write one electron that is being lost from potassium. Okay. So you can write ionization energy over here. Okay. So this enthalpy is
Yes.
ionization. Then in the next step, we know that chlorine accepts this electron. Okay. It means this electron is being added in chlorine, right?
Yeah.
So when an electron is added in the chlorine, the resulting enthalpy is called We have discussed a whole chapter. When an electron is added in a element, this is called its electron.
lattice.
No, it is called its electron affinity.
Acha,
Remember?
yes, sorry, yeah, yeah,
Yeah,
yes,
electron affinity. So it is. So we will in the next step after positive ion formation. Next step is formation of negative ion. So negative ion means you have to write electron affinity, and obviously in this step only chlorine would be changed. Now there is this situation: potassium and chlorine ion, gaseous state, and now you can see arrowhead is going toward. Basically, it is going in the forward direction. Okay, we can see that because chlorine in this one, chlorine is accepting electron. Obviously, arrow will go downward. The reason is because now it is converting into chloride ion. Okay.
yeah.
Now we have two ions, two both in gaseous state. The resulting enthalpy, and now just write that it means potassium and chlorine are reacting with each other to form potassium chloride. And this type of enthalpy or energy change during a reaction is called lattice energy. We have discussed the definition of lattice energy when when 1 mole of ionic compound is form the two ions in gaseous state. So you
From
can
one
see,
gaseous atom, I understand things. Yes.
sorry.
No, I just said the definition.
Yeah. So if you know the definition, then it is very clear that in which direction you will write arrow. Okay. Arrow is only toward, you can say, in forward direction, according to the definition. According to definition, enthalpy of formation is conversion of solid in solid. 1 mole of a compound is formed from its element in the standard state. So that's why it is going in the forward direction, potassium chloride. So that's why we wrote arrow downward. Okay. And then the most important thing, while calculations, while calculations, just remember a downward arrow means exothermic reaction and upward arrow means endothermic reaction. It means a downward arrow would always be negative. The enthalpy change here would be negative, and all the arrows that are in positive, these are in endothermic. So enthalpy change of this reaction would be positive.
Endo is going up and exo is coming down.
Yeah, definitely.
Okay.
Okay. Okay. Okay, next is calculations. This is the most important part that you were asking. Okay. In calculations, just write, first of all, write this thing, del HF, and then all the enthalpies. First of all, in the same sequence, atomization, add all these enthalpies, atomization, ionization, and then electron affinity, and then lattice. In order to find out enthalpy of formation, this one, the first step, this one, add all other enthalpies. Atomization of potassium, atomization of chlorine, ionization energy, electron affinity, and it means in the paper they will give you the values of each enthalpy, like atomization, both atomizations, because we have two compounds. Obviously, first one will convert into gas and then the second one. Okay, so they will give you the value of electron affinity, ionization energy, and both atomization energies, and as well as lattice energy, in order to find out enthalpy of formation. Okay, so just take enthalpy of formation and then add all other enthalpies. You will get the value of del HF. Okay, but in some
Yes.
questions they will give you enthalpy of formation and they will say that find out enthalpy of lattice enthalpy. So now the best thing is, first of all, write the same formula that as it is written over here, and then you can rearrange it. Okay, just write if lattice enthalpy is here, when we rearrange this equation will become only del HF is positive, all others are negative. Right? Now the idea, again you can see the arrow of it, all these things were in upward direction. Remember? And you can see
Yeah.
there is a negative sign with all these enthalpies. And del HF is positive and its arrow in the diagram is also downward. Okay, so it
Yes.
is opposite. Clear?
Yeah.
Yes. Okay. Now you have to now there is a question. Construct a Born-Haber cycle for MgO. Again, the same. This is an ionic compound. Just remember the sequence. First of all, del HF. Second, atomization. Third, ionization energy. Okay. Now there will be okay. Now there is a difference. Magnesium oxide. How many electron can be lost by magnesium? Magnesium loses how many electrons?
Magnesium.
Mhm.
Magnesium loses two.
2 electrons. Okay, so while writing electron ionization energy, we wrote in this one this potassium loses 1 electron and forms K plus, right? But in magnesium,
Yeah.
because magnesium loses one more electron, so there will be one additional step. This is called ionization energy 2. Okay, so in this step magnesium will lose 2 electrons, so now its charge is Mg plus 2, and again Cl would be the same, and then electron. So there will be one additional step for magnesium because it loses 2 electrons, so it will lose electron one by one. Okay.
Yeah.
Yeah, then again all other things are same. In the same way for oxygen, oxygen takes how many electron when it is bounded with oxygen? If magnesium is losing 2 electrons, so how many electrons will be accepted by oxygen?
Two.
2 electrons. So acceptance of electron is called electron affinity. So in this case, oxygen will have 2 electron affinities. First one when it gains, let's say minus 1 charge, and then there will be one additional step in which oxygen takes one more electron to form O minus 2. Okay. So
Yes.
balancing charges is also important. Okay. So first of all, the best thing is first of all write MgO and write the charges. We know that magnesium forms +2 charge, oxygen form -2 charge. It means while constructing Born-Haber cycle, you have to draw two ionization energies for magnesium and 2 electron affinities for oxygen, EA1 and EA2. Okay.
Yeah.
Yes. So for magnesium, how we will construct the Born-Haber cycle, which can be used to calculate the lattice energy of magnesium. Okay, one second. So what will you do? We know that it is magnesium chloride, magnesium oxide. Just write first of all magnesium oxide. Okay, okay. Now you will tell the sequence of steps. First of all, I'm writing magnesium oxide solid. Okay, so the first step is. Do you remember this first step?
Um,
Mhm.
First the electrons, yeah.
For constructing Born-Haber cycle, the first step is sequence of step is important. Enthalpy of
Enthalpy of unity, that one.
formation. Okay.
Yeah, okay.
First of all, you will write enthalpy of formation. It means at first place, in the first you can say blank, you have to write enthalpy of formation. Okay. So this is a sequence that you need to remember. Enthalpy of formation. I'm writing the sequence, then you will remember enthalpy of atomization. Okay, that enthalpy of ionization, then electron affinity, and then lattice energy. Okay, remember the sequence. Okay,
Yeah, okay.
yeah. Okay, so it means first step is enthalpy of formation. So what should I write on this blank? If we want to find out enthalpy of formation, so what should I write over here? What type of ions? Hmm? If we want to find on enthalpy of formation, just write an equation for formation of magnesium oxide. Okay, and the definition is, okay, I'm writing all the definitions. Okay, when 1 mole of compound, any compound, is formed from its elements. Okay, it is called del H. The resulting energy would be called as del H. Okay, it means if we want to find write an equation for 1 mole of MgO, okay, we have to write the
Yeah.
element. They said 1 mole of a compound is formed from its element. Now tell me what type of elements are involved in the formation of magnesium oxide.
What type of
Elements are present in magnesium oxide.
MgNO, magnesium and oxygen?
Yeah, very good. Okay, so element, just write element while constructing a one Haber cycle. First of all, write equation for enthalpy of formation, then it would be very clear. It means you have to write magnesium plus
Just suppose
oxygen.
you have read Mg plus O.
Yes,
Okay.
because they said 1 mole of a compound is formed from its element, and we know element is magnesium and oxygen. But one more thing, because in physical chemistry state symbols are important, and they said in the definition is in their standard state. So all elements are present in their standard state. Can you tell me the standard state of magnesium?
You mean that number?
No, standard state, whether it is solid,
Yeah.
liquid, or gas at room temperature.
Solid.
Very good.
Sorry, gas.
No, no, it is solid. Okay. At
Solid.
room
Okay.
temperature, magnesium is a metal, it is solid. And oxygen is
Oxygen is gas.
gas, definitely. And magnesium oxide is solid because it is an ionic compound, and all ionic compounds are solid. Okay, now we have an equation for enthalpy of formation. For writing this one, it means you should write, just write in the first step, just write the elements, magnesium and oxygen, in their standard state. Okay, and the direction of the arrow would be downward or upward.
This one is upward, yeah.
Upward how? In this, just look at this equation.
Which
This is the standard one.
one?
Okay,
MgO to that one, yeah.
so you are saying that this one,
Yeah.
it is okay. If you write like this, this now it means magnesium oxide is forming solid and half oxygen gas. So now if you write this arrow like this, now it means magnesium oxide is decomposing to form its elements. But enthalpy of formation is not decomposition, it is opposite. It is magnesium and oxygen react with each other to form magnesium oxide. So your arrow should be like this, in as this is in this equation. You can see it is toward magnesium oxide. Magnesium oxide compound is the product in this reaction. Okay, so arrow should be toward the product. Okay,
Oh, yeah.
is that clear? So now it is downward. It is definitely downward because when we are writing enthalpy of formation, so just 1 mole of a compound is formed. So compound is a product from its elements. So it is forming from its elements. So it means elements are joining together, they are combining together to form this product. So arrow should be toward the product. Okay. In this equation, you can see arrow is toward the product. So you should write over here as toward the product. Is that clear?
Yeah.
Yes. So understand the basic concepts and then you will learn. Okay. Now we have written enthalpy of formation. Now we have to convert it into, okay, next step is automation. Okay. So what is automation? Mm-hmm. Auto
Now you'll for like it's electrons, yeah.
automation. What is enthalpy of automation?
You'll do
Definition.
Mg2 plus.
Um, okay, conversion into ionic form is automation.
Yeah.
Think again. Think again. We have studied automation. convert to gaseous state, something. Remember?
Acha, yes, yes, it's true. Yes, yeah.
Yes. Automation means, okay, automation means solid to gas. Okay. In this one, we have magnesium and oxygen. Oxygen is present in molecular form in gaseous state. So we have to convert this magnesium into gas and oxygen into its atomic form. Okay. So in first step, so you will convert these one by one. So first of all, convert magnesium to solid. Okay. So you will write sorry, magnesium to gas. So from solid to gas, magnesium goes from solid to gas, and write oxygen as it is, because in this one only you will write step by step. Okay. So this is now, this shows enthalpy of atomization of magnesium only, because we have written oxygen as it is. So the resulting change in enthalpy would be enthalpy of atomization of only magnesium. Okay. Okay. Now tell me, on which side arrow goes, upward or downward?
No.
Downward. Again, think again, from solid to gas. If we are
It's all,
saying that,
yes, 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 yes.
yeah, if we are saying it is converting to solid to gas, so you have to write arrow toward solid to gas, right? It is going from solid to gas, right? Is that clear? Just keep in mind the total definition, or you
Yes.
can say the original concept, and then draw the arrow. Okay, so it is solid. In the previous case, it was from elements to ionic compounds, so we will write downward. In this one, it is from solid to gas, so we will write upward. Okay,
Yeah.
yeah. In next step, now you have to convert this oxygen into its atomic form, because if it is written as O2, it means it is in molecular form. Okay, but we want oxygen only in
This,
atomic form.
this change in FNA and then changes this ATM is always the same. Like
No, no, no. It is changed. It is different.
it can change, that means.
Yes. Okay, for you, okay, are you saying that enthalpy of enthalpy of atomization of magnesium? Yes, it would be same
No,
in every compound. Enthalpy of atomization will be the same, whether it is
I'm
magnesium
asking,
chloride.
it's always, no, like, is uh, change in affinity always first, yeah? Like,
Mm-hmm.
is it, this one, say, I'll show it. Like this one, yeah?
Mm-hmm.
These
Yes.
two, is it possible this one comes first or this one
No,
comes second?
no,
Yeah, that's always same, yeah?
it is not possible. Okay.
Yeah, sure.
Yes,
That means always same. It's always same like this.
yes. Sequence should be the same. First
Okay.
formation, then atomization. Now, and atomization again. One. First of all, we will write atomization of one atom, then atomization of second. So in this first case, we have done the atomization of magnesium, and now we will go toward oxygen. Okay, sequence will always be the same, and I have written the sequence over here: enthalpy of formations, atomization. Okay, so sequence, you should remember the sequence. Okay,
Yeah, yeah, okay.
yes. Okay, now we will convert this oxygen, and write the atomization energy of oxygen as well. Okay, atomization energy, write magnesium as it is, and oxygen in its atomic form, gaseous form. Okay, now we have converted basically oxygen, molecular oxygen, to atomic form. So basically, it is also enthalpy of atomization, right? So okay, so
Yeah.
in which arrow? So the direction of arrow would be, we are going
It's moving from
from.
gas to,
Mhm. It is basically moving from molecular form. You can see O2 to oxygen.
it's going up.
Up, very good. Okay, now I think things are clear. Very good. And this enthalpy of atomization is called oxygen. Okay, enthalpy of atomization of oxygen. First one was for magnesium. Okay.
Yeah.
Okay. Now second. Now enthalpy of atomization is completed. Third step is ionization. Okay. So ionization means, what will we do now? Ionization, ionization energy. Can you explain ionization energy?
For ionization energy, now we'll put this as
Mm-hmm.
Mg
Yeah.
plus V minus that one.
Very good. But we cannot write Mg plus 2 directly. Okay. Electrons will be lost by magnesium one by one. Okay, because we know that ionization energy 1 has different value. Ionization energy, when an atom loses 2 electrons, this is second ionization energy. So both these values are different. So you will lose electron one by one. Okay. First of all,
Okay.
magnesium will lose 1 electron. So it will form Mg plus. And when we say 1 electron is lost, and write oxygen as it is. Okay. So this
Yeah, yeah.
is, so okay, now direction of arrow would be,
This one direction arrow is up, down,
okay, think again.
up. Yeah,
Up. Okay.
yeah,
Because we are converting magnesium to Mg plus 1. So obviously on the forward direction, Mg. Okay, now magnesium, we know that as you said, magnesium converts into Mg plus 2. So now it will lose one more electron. Okay, so it will lose one more electron. And after losing one more electron, it forms Mg plus 2. Okay, and now you'll write one electron is lost, so you'll write one electron and write oxygen as it is, because we are just finding out ionization energy, and ionization energy only belongs to positive charges because electron is being removed from magnesium atom. Again, it is going in the up direction, obviously from Mg plus 1 to Mg plus 2. Clear?
yeah.
And this is called ionization energy 2, because second electron is lost, so it is ionization energy 2. First it is first one was electron ionization energy 1. Okay.
Yes.
Okay, now next step. So ionization energy means magnesium was present, so we have written two ionization energies. Now the next step. Next step is electron affinity. Okay.
Oh, yeah.
Okay. So just, so at electron affinity, you will go down. Okay, on downward, because you have to write a cycle, and cycle means, it means one from one point a cycle starts and ends at the same point. So that's why we have to go downward. Okay.
Yes.
Yes. Okay, next is electron affinity. Okay, any idea what will you do now? Electron affinity did it. Electron affinity means,
Um,
mhm,
this one will probably be
mhm.
not sure for this one.
Sorry. Yeah, oxygen, yes, but oxygen will
Oxygen will go for like taking.
taking electron. Very good. Definitely, because electron affinity means attraction for electron, and oxygen will gain electron. Very good. And it will also gain electron one by one. Okay, two electrons are lost by magnesium, so oxygen will gain two electron, but one by one. Okay, so again,
Yeah,
you'll write magnesium as it is. There's an Mg plus 2, but this oxygen will gain this electron to form O minus 1. When an atom gains electron, it develops a negative charge, right?
yeah.
Yeah, negative. Okay, so now the direction of arrow would be
This direction is downwards.
downward, definitely, because it is going from oxygen to minus 1. So either it is upward or downward. Just note that the reactant is oxygen and product is minus. So your arrow should be from reactant to product. Okay, whether it is upward or downward, just remember it is going from reactant to product. Our reactant was oxygen, it is taking electron to form oxygen O minus 1. So definitely it is going downward. Okay.
Okay.
Next, as we said, two electrons are being lost by magnesium. So obviously oxygen will gain two electrons. So write magnesium as it is, Mg plus 2, and oxygen will gain one more electron. Okay. So after gaining one more electron, it becomes which ion? O minus 2i, right?
Yeah.
Okay, so direction of arrow again downward from O minus 1 to minus 2, right?
Yes.
Okay, so state symbols are important. So you have to write state symbol in every step. Otherwise, you will lose marks. Okay. State symbols means solid, liquid, or gas. We are writing G, 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 G everywhere. All these compounds are in gaseous state because we have atomized them. Okay. So now the first one, when oxygen gains one electron, this is called electron affinity 1. Okay. Second time when it gains electron, it is called electron affinity 2. Okay.
Yeah.
Now the last step. Okay. Now we have Mg plus 2 means ionic form, one positive and one negative, and it is form an ionic compound. So direction of arrow would be obviously form ionic compounds to the form ions to the ionic compound. And this type of enthalpy would be called as when one mole of ionic compound is formed from its gaseous ions is called
This
Mhm.
um
Ionic compounds are associated with what type of energy we have discussed. Ionic compounds, regular arrangement.
optimization.
Uh, Fifth point is see fifth point. This is written over here.
Or lattice energy. Yeah, yeah,
Lattice energy.
I'm just seeing this drawing again.
Yes, del H of lattice. Okay, so that's how you will draw a Born-Haber cycle of any compound. Okay, just note the sequence. You cannot change the sequence. And if you know the definition, then it is very clear that you will not make any mistake. If you know atomization is conversion of solid to gas and into atomic form, so definitely you will do the same. And if you know ionization energy is removing electrons, so obviously you will write positive ion for this compound. If you know electron affinity is gaining electrons, obviously you will write, you will add electron in the atom. Okay. So basically
Yeah.
definitions are important, and then all the state symbols, and then you will, and the sequence of events. Sequence of, just remember the sequence. Okay, this is very important. Okay, now in the question they said, write a Born-Haber cycle which can be used to find out lattice enthalpy of the reaction. Okay, so how we can
Yeah.
use it to find out enthalpy of formation. So for this purpose, write all the enthalpies and del HF equals to del HF. Okay, so first formula that you'll write while looking at this enthalpy cycle is, first of all, write del HF. Even in the if in the question they say find lattice energy. Okay, I suggest that first of all write del HF. Okay, then it would be very clear, and you will avoid mistakes. Del HF, and now just add all these energies. Okay, one by one, just add enthalpy of automation.
These we have to write both or any one of them.
Both, both ionization energies, both enthalpy, electron affinities, both. Okay,
Okay.
so start from one end. Okay, from this side, start from this side. Del H atomization of magnesium, then add en- enthalpy of atomization of oxygen, plus add ionization energy 1 plus ionization energy 2, then electron affinity 1 plus electron affinity 2, and last one is lattice energy, del H lattice. Okay, so these values will be given in the question. But first of all, write enthalpy of formation, and then you can rearrange this equation to find out del H lattice. Okay, now if you have this equation, you can just easily rearrange it, okay, to find out for del H lattice. Okay, because all these things are being added. So if we write the other equation, and now they are all these have positive signs. So when they go on the left side of the equation, they all will be negative. Okay, del HF is already present. Okay, and it is positive, so just write del HF as it is, and then all these values, transfer all these values to the left hand side, and they will become like this: del H atomization of magnesium minus del H atomization of oxygen minus ionization energy 1 minus ionization energy 2 minus electron affinity 1 minus electron affinity 2. So this equation, you can use this equation to find out del H lattice of this reaction. Okay.
Just to find the lat and the up one is for find the formation.
Sorry, your voice is not clear.
The up one is for finding the formation, yeah, change in formation.
Yes. Yeah. This equation is for enthalpy of formation. You can just add all these values, and for lattice energy, then definitely you have to move these all these values to the left hand side, and then the equation would be like this. In this equation, only del HF is positive, all others are negative. Okay, because when we rearrange this equation, the all the things that are present on the that are positive, when they go on the opposite side of the equation, they will be negative. This point is clear.
Can you make it a like the screen a bit small, like as in like I can so I can see the full thing.
Yeah.
Yeah, just one second. Yeah, okay.
Okay. Okay. Recall the sequence. Okay. So this sequence is written over here. So can you recall it? Okay. I'm just, yeah. Now tell me the sequence of all the enthalpy changes in Born-Haber cycle. First of all, we
Um,
will write. Mhm.
like first we'll do formation like
Very good.
that.
Yes, definitely.
Um, you want me to say it? All the
So yes, just tell me.
okay. First is we'll do enthalpy of formation.
Very good.
Then we'll do atomization,
Definitely.
then ionization,
Mhm.
then the affinity, and then the lattice energy.
Electron affinity and then lattice energy. Very good, very good. That's correct. Okay, and then you will note it down whether whether it contains an element which has two ionization energy. Let's see if we have magnesium. So obviously we know that it loses two electron, and oxygen accepts two electron. There will be some compounds like NaCl. We know that sodium only loses one electron, so it has only one ionization energy. Okay, and chlorine only accepts one electron, so it will have only one electron affinity. Okay, but this atomization process is important. We have to convert both elements into their gaseous state. First of all, you will convert one substance, like in this case we have discussed for magnesium, and then for oxygen as well. Okay, because students basically think that atomization energy is just the conversion of solid to gas, and when they write this step, they just write, let's say for if we write sodium chloride. Okay, for sodium chloride it would be like this: sodium chloride, sorry, it's Yeah, let's say it solid plus half chlorine gas. So while writing automation energy, they just do convert sodium into gaseous state and then skip the process of automation of chlorine. Definitely it is enthalpy of automation of sodium. Okay, but in the next step you have to atomize or convert this chlorine into atom also. Students just see this equation and they say chlorine is already in gaseous state, so it means there is no enthalpy of atomization for chlorine. But no, for enthalpy of atomization there is one thing is conversion of solid into gas, the other thing is conversion of molecular form to atomic form. It means if a compound is present as oxygen, Cl2, it is its molecular form. You have to convert it into its atomic gaseous form. Okay. Even if it is present in gaseous state, but now it is in molecular, you have to convert it into atomic state. Okay. For this reason, you will add one more enthalpy of atomization and convert chlorine. This is half chlorine means one chlorine. So you'll write chlorine gas. Now we have converted this molecular chlorine into atomic form. This enthalpy is called enthalpy of chlorine, enthalpy of atomization of chlorine. Okay. This step is important. Mostly students miss this step because they think chlorine is already in gaseous state, so we don't need to convert it. No, you have to convert it into its atomic form, even if it is in gaseous state, but it is in molecular form. Okay. This point
Yes.
is clear. So that's why we did at this position. At this position, we have written atomization of oxygen as well. So you can see we have converted O2 to O gas, atomic form. Okay.
Yeah.
Yeah, this point is important, and then the sequence is important. Any other question, Vasi?
No.
Okay. 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 So this is the whole thing. Then calculating bond Haber cycle. We have done this thing. Okay. Basically, again, del HF, first of all, write del HF is equals to atomization of both elements. You can see, and then ionization, electron affinity, and del H of lattice. So you can rearrange this equation to find out del H lattice of this reaction. And this basically, when we write these 3 points, these 3 bars, it means all the atoms are in standard state or standard lattice enthalpy. Okay, this thing, or sometimes we use 5. Okay, it means standard lattice enthalpy. Okay.
Yeah.
Okay. Okay, so they can be a bond Haber cycle could be used to calculate any stage in the cycle. Okay, so in some reactions, you could be given the lattice energy and asked to calculate the enthalpy of it because we know the formula now. Okay, why? And now we know the formula. Del HF is equals to del H1. Del H1 is basically sum of all the enthalpy change. Means atomization plus ionization energy plus electron affinity. So they are collectively called del H1, let's say. Okay. So it
Yes.
is del HF is equals to del H1 plus del H lattice. So we can rearrange this equation to form del H lattice. So they can ask questions like this. Sometimes they will ask question to find out del HF. Sometimes they will ask questions that find the value of del lattice. Okay. So you should be able to rearrange this equation to get the answer. Okay. Clear?
Yes.
Okay. Now calculating the lattice energy of potassium chloride. Again, you will, yeah, okay. In some this type of questions, they will give the values in this form, in tabular form. And you should remember the formula del HF is equals to all the, you can say, enthalpy of atomization, ionization, plus electron affinity, plus lattice energy, right?
Yeah.
So yeah, so in this equation, you can see Atomization is given, ionization energy is given for potassium separately, chlorine separately. Atomization is given, ionization energy of an electron affinity. For this potassium, it is obviously electron ionization energy because it loses electron. Okay. For chlorine, it is electron affinity because electron is being added in chlorine. Okay, so all these values are given. Del HF is also given minus 436. Just put the values in the equation and find out the del H lattice. Okay, let's see. When we rearrange this equation, it would become del H lattice, del HF minus del H ATM for first of all potassium minus del H AT for atomization for chlorine. Then again minus ionization energy minus electron affinity minus no, now it is okay. Okay, because we have rearranged this equation. Okay, now del HF is minus 437, right?
Yes.
Okay, minus 437. Okay, now carefully write all the minus signs. So then negative, and then write the atomization energy of potassium is plus 90. Okay, so you should write plus 90 in bracket first. Enthalpy is plus 90 and there is minus in the formula. So you have to multiply it with. In the next step, we will do. Then for the enthalpy of atomization of chlorine, it is plus 122. So just write minus plus 122. Next is ionization energy of potassium. Ionization energy is plus 418. Then minus electron affinity is minus 349. Then, yeah, definitely. Now it's okay. Okay. Now multiply all the signs. Minus 437, minus plus, minus 90, minus plus, minus 122, minus plus, minus 418, and minus minus plus 349. Okay, so that's why signs are important. Otherwise, you will lose marks because if you don't write carefully the and the signs. Okay, now you can see minus minus plus. It becomes 349. Then,
Basically, you should know the entire step of a change in affinity minus this, that.
hmm, yes.
Yeah.
Then this solve this equation. Minus 437 minus 90. It will give you answer would be, let's see. Okay, so you can construct, if they say in the question construct, then you will construct. Otherwise, you can just calculate it. Minus, it is minus 718 kilojoules per mole. Okay, just remember, if in the question they say draw Born-Haber cycle, then you will draw. Okay, otherwise, you can just easily write the formula. So it depends on the marks of the question. If it is, say, 4 marks, obviously you have to draw Born-Haber cycle. Okay, otherwise, if you remember the formula, then it is very easy for you, and you know the sequence as well. It is very easy for you to get the answer. Okay,
Yes.
any question, Wasi?
No, this one is basically all based on the learning that step or formula.
Yes,
Yeah.
yes. Okay, so if you know the sequence and this and the formation is equals to, add all these things and then you can rearrange and then put the values, you will get correct answer. Okay,
Yeah. Okay.
okay, okay. Then next topic is factors affecting lattice energy. Okay, as your homework, I will give you you have to draw the let Born-Haber cycle for NaCl. Okay, Born-Haber cycle for NaCl. In your homework, you will do this and send me on WhatsApp. Okay.
Yeah. Okay.
Yes. Next topic is factors affecting lattice energy that we will discuss in next lecture in detail. But basically, there are two factors that can affect the lattice energy. This is ionic charge and ionic radius. Ionic charge means the charge on ion. It would be positive 1 plus 2 plus 3. Okay. And radius means the size. Because as the size is increasing, basically how an atom gets positive charge. Let's see. When sodium loses its one electron, it gains plus one charge, right? So,
Yeah.
so when we draw its structure, it would be like this: 2, 8, and 1. So in normal state, sodium has 11 electrons and it has one electron in outer motion, right? But when it loses its one electron and to become Na positive ion, now its structure would be like this. Obviously, in the third shell, there was only one electron. After losing that electron, it loses the shell. Okay. Now you can compare. Now its size is decreased, right? So after losing electron, because the nucleus, one more thing is nucleus attracts the remaining electron more strongly after losing electron. So that's why size decreases. So in this way, ionic charge and ionic radius are related to each other. Okay. In the next lecture, we will discuss how ionic charge and radius affect lattice energy of a crystalline compound. Okay.
Yeah. Okay.
Yes. But your homework is draw Born-Haber cycle for NaCl. Okay. Okay, Vasi. If you need help, you can ask
Thank you.
anytime. I'm available Monday to Friday. You can easily ask questions. Okay.
Yes.
Okay, Vasi. That's enough for today. We will start next lecture on Friday, same timings.
Okay.
Okay. Allah Hafiz. Take care.
Allah.